Okay, and a lot of the problems that you'll be doing in Chapter 12 in the tangent normal and also in the r theta, the polar coordinates, you need to take multiple derivatives with respect to time. So in this particular case, I just want to show you how to use the chain rule properly to make sure that you do it correctly. So suppose you have some function like r equal 4 times an angle cubed, and r and theta are both functions of time. So as time goes by, these guys change. They're not constants. And what I want to do is I want to find the derivative of r with respect to time. Those things are going to be called r dots. So a dot means the time derivative of this. Okay, so let me show you how to do it. You can do the substitution, so you take the derivative with respect to theta and all that. And that's true, but you don't really want to waste the time to do the derivation. So I'm just going to show you how to do it. Okay, so in this case, you want to take the derivative of a constant times this function. So according to the rules for derivatives, you take the constant out in front. Then you multiply that constant times the derivative of what's on the inside, right? What it multiplies. So I want the derivative of theta cubed. Well, that's something raised to a power. So you use the power formula. So that would be bring the power down times the stuff being raised to a power to the power minus 1. Okay? And then you have to apply the chain rule times the derivative of what's inside times the derivative of theta. So the time derivative of theta is d theta dt, and that is theta dot. Now you can tell if you're using the chain rule properly because you can add the number of dots in each term. So over here on the left hand side there's one term and there's one dot. On the left-hand side, there's one term, and that term has one dot in it. So those guys match, and so you're confident that you did the derivative properly. Okay, so now suppose I want to take the time derivative of r dot. That is going to be equal to r double dot. Okay, so now what I have over here, let me just simplify this. This is going to be 12 theta squared theta dot. Okay, so over here it's a constant times a product. So to take the derivative of that, you bring the constant out, and now you have a product. So the derivative of the product is the derivative of the first term, theta squared. So that's bring the power down, stuff being raised to a power to the power minus 1, times the derivative of what's on the inside, theta dot. So that's the derivative of the first term. That's the derivative of this piece right here. And then that's the first term, so then you multiply by the second term. Then you add this product formula. Then you add the first term times the derivative of the second term. So that would be d theta dot dt. And that is theta double dot. Okay, so let's see if the number of dots match up. So on the left-hand side you have one term and it's got 2 dots in it. On the right-hand side you have 2 terms, this term here, and it has 1 dot there, another dot there, so that's 2 dots. Here's the second term, and it has 2 dots in it. So I believe I did the chain rule properly.